Okay, we're still on lesson 22-1. We're at number 6. It says, hey, wants us to go back and look at these grids right here. Okay, it says some of these triangles are similar to each other. And they want us to identify the groups of triangles that are similar to each other. We need to explain how they're similar. And it's giving us a hint right here saying that there's going to be a group of 3 and there's going to be a group of 2. Now, mine were such a hot mess, I don't even want to try to look at all that. So we're going to look at the teacher's version. They did a much nicer version. They drew the triangles and they wrote the answer down, and that's all there is. So it'll be easier for us to see. Okay, I can identify the group of 3 really quickly. And that's the ones that are 3, 4, 5 triangles. Okay, so you can recognize that they are similar. So let's see which ones it is. It's A. It's grid A right here. A, C. And the reason that I can recognize them so quickly is because they're the only ones that came out with integer answers. Notice that all 3 of the numbers are integer values. That's the sign that they are a Pythagorean triple. I mean, if it comes out where all 3 side lengths are exact values, then it's a Pythagorean triple. And since they're all a 3, 4, 5 triple, this is a 3, 4, 5 triple right here. It's just by a scale factor of 2 to 1. All you got to do is take 3 times 2 and get 6, 4 times 2 and get 8, and 5 times 2 and get 10. So this has a scale factor of 2 to 1. This one is a 3, 4, 5 with a scale factor of 3 to 1. Because 3 times 3 is 9, 3 times 4 is 12, and 3 times 5 is 15. So those are easy to recognize. So it's A, C, and E. Those are Pythagorean triples, 3, 4, 5. So that would be my description. And one of them has a ratio of 2 to 1. C to A has a ratio of 2 to 1. And C to E has a ratio of 3 to 1. Now, the other 2 that are left, so we obviously, we're not going to use this one, we're not going to use this one, and we're not going to use this one. So that leaves these 3. Just by looking at the triangles, it looks like these 2 should be similar to me. And that's because the long leg and the short leg are pretty close to the same size. This one right here, the long leg is a good bit longer. Well, it's double the short leg, and this is not the case over here. This is not the case. So since the relationship between the long leg and the short leg is not the same here, then it's likely that these 2 are similar. And we can see that if you take 4 and 5 and double it, you get 8 and 10. And if you take 6.4 and double it, you get 12.8. So the other group is B and D. And this one has a ratio of 2 to 1 to go from B to D, because you just doubled each one of those and you get these. Okay, so that's answered question number 6. Now they're going to get to, this is the most important part. I'm telling you, if you will not be able to do, if you are having a hard time doing trig ratios, that's because you don't understand this. So in a right triangle, you obviously have the hypotenuse. The hypotenuse is easy to identify. It's the side that's across from the right angle. So the hypotenuse is always called the hypotenuse. But the other 2 sides are legs, okay? And so this is a leg and this is a leg. But we have to talk about these so that we can distinguish them. And the way that we distinguish them is based on what angle we're referencing, okay? So in this triangle right here, for angle A, if I'm looking at angle A, the leg that's opposite angle A, when we're talking about angle A, we call this the opposite leg. But we can't just say it's the opposite leg. We have to say it's the opposite leg of angle A, because if you don't know what angle you're talking about, then you can't call it the opposite leg. Same thing is true for this one. If we're talking about angle A, then this leg right here is going to be what we call the adjacent leg, because it's the leg that's next to or connected to angle A. So for angle A, this is the adjacent leg and this is the opposite leg. But in that same triangle, okay, I'm just going to, instead of drawing it again, I'm just going to delete that. But in that same triangle, okay, we still have this is still the hypotenuse, because the hypotenuse is opposite the right angle no matter what. But if we're talking about angle C, and then we want to talk about this leg right here, then for angle C, side RA, it is a leg, but for angle C, it's considered the opposite leg. And the same thing is true for the leg CR. If we're talking about angle C, this is a leg, okay? It is a leg, but for angle C, it's the adjacent leg. So in trig, when we're working with trig ratios, the most important thing is that you be able to identify, first of all, which angle you're going to be working with, and then after you identify the angle you're going to be working with, you have to identify what the other legs are, and which one is the opposite, which one is the adjacent. So it says for this triangle right here, triangle BUS, identify the opposite leg and the adjacent leg. Notice it says for which angle, okay? Now, it didn't tell me to identify the hypotenuse, but you should, because that's the place to start, because it rules out one of the legs. If you've labeled the hypotenuse, then you can't accidentally label it the adjacent leg, and that's what usually happens. So, for angle U, opposite leg, and the only one left is the adjacent leg, and that's usually the way I always do it. So, apologize for the dogs barking. I'm not sure why. They're just being crazy. So, you can do the same thing. They don't ask you to. Do they ask you to? Nope, it goes right to check your understanding. So, I'm going to do it again. We're going to, that's the answer for angle U. Let's redraw the picture. And let's do it for angle B, okay? S, B, U. Okay, so here's the right angle. So this is the hypotenuse. I'm asking you to label it for angle B, opposite and adjacent for angle B. Okay, so for angle B, go this way for opposite. And then the only one left is adjacent. Okay, this is probably the most important part of this lesson, is being able to label opposite and adjacent legs, because that is the starting place for all of your trig ratios, sine, cosine, and tangent. Okay, so I'm going to stop this video here, and I will start my next one going over the answers to the check your understanding and the practice.